CEC Conductors. What is a conductor? A material that permits electrons to flow freely from particle to particle. A means to allow current to flow from the source to the load. Conductor ampacity. The conductor must be large enough to carry the current required by the load. This conductor's capacity rating is called ampacity. The conductor with a higher ampacity rating means it has a larger surface area. A larger conductor has higher ampacity, more current capacity. The smaller conductor has low ampacity, less current capacity. Conductor insulation. There are a couple things we need to look at before we learn how to size conductors. Let's look at a conductor construction. You have the insulation, which is on the outside, and you have the current carrying material. An example could be copper, which is on the inside. The insulation has a temperature rating. This rating states the maximum heat the insulation can handle without deteriorating. When current flows through the conductor, heat is generated through I squared times R equals P. The higher temperature rating will allow more current through. Let's look at Table 2 of the Canadian Electrical Code. If we look at number 3, AWG, under the 60-degree temperature, we're allowed 85 amps through it. But if we look at the 90 degrees temperature, we can have 115 amps through it. Conductor scenarios. There are two main scenarios we need to consider when sizing conductors. 1. Conductors in free air, an open or ventilated environment that allows for heat dissipation and air to flow around the insulated conductor. The second one is conductors in raceway or cable, an enclosed conduit or tubing that forms a physical path for electrical wiring, which is also known as mechanical protection of the conductors. Conductors material. There are two main types of material used to carry current. The first one is aluminum conductor, which is a mediocre conductive material and lightweight. The copper conductor is a good conductive material and robust. General. Sizing a conductor properly requires patience and understanding. Undersizing a conductor can cause electrical hazard such as electrical fires and melting of conductors. Conductors are dealt in Section 4 of the Canadian Electrical Code, which is the CEC, and applies to service, feeder, branch circuit, and photovoltaic circuits. 4-002 Size of conductors. This rule states copper conductor cannot be smaller than number 12 AWG, and aluminum conductors cannot be smaller than number 14 AWG. The exception would be for flexible cords, equipment wiring, control circuit, insulated conductors, etc. that can be smaller. Conductor termination temperature. Termination temperature on equipment. The maximum temperature the equipment is allowed to see. 4006 temperature limitation states that the ampacity of the conductor shall be derated if the termination temperature is lower than the insulation temperature. Example, we buy a roll of copper number 4 AWG RW90 from the local hardware store and plan to install this in a raceway. So if we look at table 2, and number 4 from the hardware store at 9-degree column, we see we have 95 amps. But when we install this at an equipment rated for a termination temperature of 75 degrees, the ampacity has to be derated. It's no longer good for 95. The number 4 now is good for 85 amps. Even though the wire is good for 95 amps off the shelf, but the termination temperature has derated the ampacity. Conductor termination temperature. To understand this better, let's try a few examples. We buy a roll of copper number 2 AWG TW60 from the local hardware store and plan to install this in a raceway. Let's recall table 2. So the number 2 wire up to the 60 degrees Celsius column, my number 2 is good for 95 amps. Let's say it terminates on an equipment rated for 90 degrees Celsius. The 60 degrees column ampacity is lower than the 90 degree column's ampacity. Therefore, we leave the conductor's ampacity as is. Conductor termination temperature. To understand this better, let's try one more example. We buy a roll of copper number 6 RW90 from the local hardware store and plan to install this in a raceway. Let's recall table 2. A number 6 RW90 90 degrees column is good for 75 amps. But let's say we terminate this on a device rated for 60 degrees. Therefore, under a 60 degrees column, the 75 amps is actually good for 55 amps. Even though the wire is good for 75 amps off the shelf, the termination temperature has derated the ampacity. Conductor sizing. Conductor sizing will be dealt in another video. Thank you for watching. If you haven't yet liked or subscribed, please do so, as it's an indicator that you're liking my content. If there are any concerns, please feel free to leave a comment below. Have a happy learning experience.